Morning, Calculus. It's Wednesday, March 18th, and I'm up here with an empty classroom, which is awful. I miss you. I'm going to be recording your lessons for this last unit in case we don't get to come back after spring break. ETS, the Education Testing Service, is working on how you're still going to be able to take your exams. I will keep you posted as I know anything. I will have blank notes posted to Classroom as well as filled in notes in the video. So hopefully that will take care of everything that you need. Remember, if you don't have a calculator, there are free ones on your Android phones or your iPhones. Today's lesson starts the last unit, as I said, and its title is, give me a second and I'll find it. The title of this unit, again, your last one, is Advanced Integration and Application. So I realized what I need to do also is I will post the rubric fiddle. I will post the syllabus for this last unit. I don't know how we will deal with quizzes or tests. Mr. Lindley will have to give me guidance on that from the guidance that he gets from the superintendent and the State Department of Health. So we'll figure that out as we go. But you can take a look at the syllabus. This first lesson, and I think Sparks has really got this out of place because this is something that I taught you in the last unit, at least to a degree, to the degree that you needed to know it then. So at least the first part of this ought to be real easy for you. The second fundamental theorem of calculus. Given the functions f of t below, use big F of x equals the integral from 1 to x of f of t dt to find big F of x and big F prime of x in terms of x. Now you notice, remember I told you that he got sloppy with his notation earlier? He's not sloppy this time. There's x, there's t. He did it right this time. Yay, Sparks. Okay. Number one, big F of x is the integral from 1 to x of little f of t dt. So big F of x is, I have to change colors so stuff doesn't get mixed up, the integral from 1 to x of 4t minus t squared dt. Now that's what f of x is. Excuse me. It says big F of x is the integral from 1 to x, okay? Now notice this is not taking a derivative. I'm not doing big F prime of x. I'm just going to actually do this integration. The antiderivative of 4t minus t squared is what? 2t squared minus 1/3 t cubed. Now the problem with this lesson is very simply that you're not here to tell me when I screw up. So I hope I do this right. Now we're going to evaluate this at x minus evaluate this at 1. So that will be 2x squared minus 1/3 x cubed minus 2 minus 1/3. So it's going to give us 2x squared minus 1/3 x cubed minus, let's see, 2 minus 1/3 is 1 2/3. What's that? 1 2/3 is 5/3. Okay, so this is big F of x. Now it asked us to take the derivative of this. Well, big F prime, we're just going to take the derivative. So what is that? 4t minus, where am I getting t? 4x minus x squared. Well, look at that. This, I'm going to have to scroll down some more, is this evaluated at x, 4x minus x squared. That's what I taught you before. So I'm not going to go through the whole process of finding this big F of x, so then you can find the derivative of it and realize that it's what I taught you in the last unit. What we're going to do here is just go directly to finding big F prime. So let me erase all this stuff. So if big F of x is the integral from 1 to x of 4t minus t squared dt, then big F prime of x means you're taking the derivative of both sides with respect to x. Remember, why is it with respect to x? Because that's what that variable is, and it's what that variable is. Remember, a derivative and an integral are inverses when you're going from or integrating from a constant to a variable, and that variable match. So we know that f prime of x, the derivative and the integral are inverses, they will cancel. So it's this function evaluated right here, 4x minus x squared. Let's look at number 2. Big F of x is the integral from 1 to x of f of t dt, which in this case is cosine t dt. So big F prime of x, if I take the derivative of the left side, I have to take the derivative of the right side. The derivative and the integral are inverses because I am integrating from a constant to a variable, and that variable match. So this is going to give us this equation evaluated at x. Now, do you remember, if this upper limit of integration has a derivative other than 1, then we have to multiply by that as well, but the derivative of x is just 1. All right, let's look at these. Given the functions f of t below, we're going to find big F of x and big F prime of x. Again, we don't have to worry about that because you already know that. So big F of x here is the integral from 1 to x squared of f of t dt, but f of t is t cubed. We're going to take the derivative of both sides. So f prime of x is this function evaluated here. So that's going to be x squared cubed times the derivative of that upper limit. Well, what's that going to give us? Well, that's going to give us x squared cubed is x to the 6th times 2x to the 7th power. Pretty cool. All right, this one. Big F of x is the integral from 1 to x squared of f of t dt, which is 6 times the square root of t dt. Now I'm going to rewrite that. I'm going to pull the 6 out because you know you can do that. Of t to the 1/2 dt. Now I may decide I don't want to write t to the 1/2. I may decide to go back to square root of t. I don't know yet. So f prime of x will be the derivative of this. So it's going to give us 6 times. Now that's going to be this t to the 1/2 evaluated at x squared. So that's going to be x squared to the 1/2 times the derivative of x squared. So what's that give us? 6 times x times 2x. I believe that gives us 12x squared. Next page. So what does the second fundamental theorem of calculus say? This should be repetitive. If big F of x equals the integral from some constant to g of x, I'm using a because that's what Sparks uses in his notes, of f of t dt, then f prime of x equals f of g of x times g prime of x. Okay. These, it's the same stuff that we did on the front page. But let's just run through it again. I'm not going to worry about this stuff, okay? We're just going to look at this column right here. I'm sorry, my phone is just binging. I'm getting texts like crazy. So sometimes I will stop and go check on them in case it's students, okay? So this column, if I want to find the derivative of both of f prime, if I want to find f prime of x, then I'm taking the derivative of both sides with respect to x. So it's going to be 4x minus x squared times the derivative of that upper limit, which is just 1. Now you don't have to do that part. You can look with your brain and know that that's 1. You don't have to write that down. Next one, f prime of x. I'm taking the derivative of both sides, so that's going to be cosine of x. The derivative of x is 1. Here, f prime of x is t cubed, evaluated at x squared, times the derivative of x squared. X to the 6th times 2x is 2x to the 7th. I know I'm going through these fast. I feel like this is easy enough for you. The integral from 1 to x squared of t to the 1/2 dt. And if I take the derivative, it's 6 times x squared to the 1/2 times the derivative of x squared. X squared to the 1/2 is x. X times 2x is 2x squared, and 6 times 2x squared is 12x squared. Yay, easy 2 pages. Just some more practice with some little more complicated functions. Find the derivative of each of the following functions. F prime of x. That's a terrible x. I don't even know why it looks like that. Okay, I'm integrating from a constant to a variable expression. That variable matches that variable, so the derivative and the integral undo each other. So this is going to be the square root of 2 minus 2x squared times the derivative of 2x. What's that going to give us? The square root of 2 minus 4x squared times 2. G. This one's a problem. Notice that I'm going from a variable to a constant. I got to swap that. So g of x is going to be the opposite of the integral from -3 to x squared of e to the cosine t. Wait a minute. Yeah, dt. Now I can take the derivative, negative. So that's going to be e to the cosine of x squared times the derivative of x squared. So we're going to write that as -2x e to the cosine of x squared. And remember that cosine of x squared is an exponent. H prime. I can take the derivative because I'm going from a constant to a variable expression, and those variables match. So this is going to give me what? T squared, but I'm going to put cosine x in for t, times the derivative of cosine x. So what have we got? Well, we've got minus sine x times cosine squared x. Now, in Sparks's notes, he goes farther. I don't think it's an issue. However, if this is a multiple choice question and this is not one of the options, let me show you what Sparks is doing. Sparks goes back to the Kahuna family. Woohoo! And he says cosine squared x is 1 minus sine squared x, and then he distributes. So what would that give us? Minus sine x plus sine cubed x. Okay. Next. Picture to the right is the graph of g of t. So this is g of t. And the function f of x is defined to be that function. Okay. So notice we are integrating a function whose graph we have. Typically that might mean area, so we're going to have to think about that. F of 0, so I'm putting 0 in here for x, so everywhere I see an x I'm putting a 0, is the integral from -4 to 0 of g of t dt. So I am integrating. Oh, it's time to come back to class from lunch. No, it's time to go to lunch. Bell just rang. I am integrating a function whose graph I have, so that means area. I'm finding the area under this curve from x equal -4 to x equals 0. So what have I got here? I've got that, and I've got that. But I'm going to do that. I hope it's obvious to you that those two cancel each other. The area of this thing is 2. This is 1/4 of pi r squared, but the radius of that thing's 2, so 2 squared is 4. So that area is pi. Looks to me like that is pi plus 2. Number 2, find the value of f of 2. Well, f of 2 is the integral from -4 to 2 times 2 of g of t dt. So we're going from -4 to 4. Well, snap. I do believe that thing has symmetry with respect to the y-axis, which means it's twice what we just did. So that's going to give us what? Twice pi plus 2. So 2 pi plus 4. Doing okay? Hope so. Find the value of f prime of 1. All right, f of x is this. So f prime of x, you have got to find f prime of x first before you can find f prime of 1, is g of 2x times the derivative of 2x. So f prime of 1 is g of 2 times 1 times 2. Well, what's g of 2? Well, I do believe g of 2 is 1. So that's 1 times 2, which is 2. F prime of -2. Well, I know what f prime of x is. So f prime of -2 is g of 2 times -2 times 2. Well, g of -4 looks to me like that's -1, eh? So that's -1 times 2, which is -2. Number 5 is f double prime. Well, f prime of x is g of 2x times 2. Let's write it like this. G of 2x, and we'll just put the times 2 in front. Well, I got to find f double prime of x before I can find f double prime of 2. So f double prime of x, I'm just going to bring that 2 down. The derivative of g of 2x, that's a chain rule, is g prime of 2x times the derivative of the inside. So that's 4g prime of 2x. Now I need f double prime of 2. So f double prime of 2 is going to be 4 times g prime of 2 times 2. Well, what's g prime of 4? G of 4 is -1. Can I take the derivative at that endpoint? No, I can't take the derivative of an endpoint because I could take the one-sided derivative, but I can't take a two-sided derivative because there's nothing there. So f double prime at 2 is undefined because g of t is not continuous, not differentiable at t equal 4. Given to the right is the graph of f of t, which consists of 3 line segments, 1, 2, 3, and 1 semicircle. Okay? Additionally, let the function g of x be g of x equals the integral from -1 to x of f of t dt. Find g of -6. G of -6 is going to be the integral from -1 to -6 of f of t dt. Now remember, this is f of t. Now the first thing I don't like about this is that we're going from -1 to -6, which means we're going from big to small. We got to turn that around. The opposite of the integral from -6 to -1. Now, because I am integrating a function whose graph I have, that's area. So I need the area under this curve from -6 to -1. So I need this, and I need this. Now I'm going to break that into a square and a triangle. Okay, so what's this? This is a triangle 1/2 of the base, which is 2, times the height, which is 4. I think the area of that piece is 4, if I am not mistaken. That's a square, 4, but it's below the x-axis, so that's -4. This is half of the base times the height. The base is 1, the height is 2, so that's 1, but the whole thing's under the x-axis, so that's -1. So I've got 4 plus -1 plus -4. Looks to me like that is -1, but I've got the opposite of it. So that's 1. g of 6. Okay, sorry for the up and down business here. G of 6 is the integral from -1 to 6 of f of t dt. Well, I can do the integral from -1 to 6, I hope, from here to here, right? Let's see here. What's that piece? Area is 6, but it's below the x-axis, so that's a -6. This is half of a 2 by 2, so that's 2, but it's below the x-axis. And then here, it's a fourth of that circle, 1/4 of pi times the radius squared. So it looks to me like that's pi. Is that pi minus 8? I like doing these problems. I think they're kind of cool. Okay, let's see where we are now. G prime of 6. All right. G of 6, or G of x was the integral. Let me write this down. G of x was the integral from 1 to x of f of t, goodness, of f of t dt. So G prime of x, if I take the derivative of both sides, is just f of x. So G prime of 6 is just f of 6. Well, what's f of 6? F of 6, 2. G prime of 2. Well, G prime of 2 is going to equal f of 2. So G prime of 2, which is f of 2, and f of 2 is -2. Find G double prime of 2. Well, if we're going to find G double prime of 2, we've got to find G double prime of x, which means we're going to take the derivative of G prime of x. Now, G prime of x was f of x. So G double prime of x is going to be f prime of x. So G double prime of 2 is going to be f prime of 2. Well, what's f prime of 2? Uh-oh. F prime of 2, right there. Remember, this is the graph of f. Can I take the derivative at that point? Nope. It's a pointy place. The calculus way to think that, though, is the derivative from the left is not equal to the limit, I should say, the limit of the derivative from the right. That function is not differentiable at x equals 2. So this is undefined because f prime of 2 is not differentiable. The limit as x approaches 2 of f prime of x from the left is not equal to the limit of f prime of x as x approaches 2 from the right. Okay, I think I see one more question on there, number 6. G double prime of -4. Well, G double prime of -4 would be f prime of -4. Well, what's f prime of -4? Now, I can do that one. That's just slope because that's a line. What's the slope there? Let's see here. 1, 2, 3, 4. Up 4, left 2. Is the slope -2? Yep. Now, let's just give a reason. F prime of -4 is the slope of f at x equal -4. One more page. The continuous function shown is f, so this is f. It is defined on a closed interval. The graph consists of 2 quarter circles. So there's a quarter circle, and there's a quarter circle, and 1 line segment, which you can see, and we're told what g of x is. All right, so this is f, and then we're given an equation for g. Find the value of g of 3. All righty. G of 3 is going to be 1/2 of 3 squared plus the integral from 0 to 3 of f of t dt. Well, that's going to be what? 9/2 is going to be that part, plus we are taking an integral of a function whose graph we are given, so that's area. We want the area from 0 to 3. So I want that plus that. Okay. They look pretty close to the same, don't they? What's that? I'm looking at this one. So that's half of the base is 2, and the height is, what is the height? 3. So that's 3. Well, this was the same thing, except it's just below the x-axis. So that is 0. So answer 9/2. Next one. Find the value of g of -4. Well, g of -4 is 1/2 of -4 squared plus the integral from 0 to -4 of f of t dt. Half of -4 squared, -4 squared is 16, half of 16 is 8. Now notice here we're going from a big number to a smaller number, so I'm going to have to change that around and make that a minus. -4 to 0 of f of t dt. This is the area under that curve from -4 to 0. Oops. -4 to 0. So here to here. So I need this, and I need this. So we'll start with this one. 1/4 of pi r squared. What's the radius? Looks like the radius is 1. So that's 1/4, but negative because it is below the x-axis. This 1/4 of pi times its radius. What's its radius? 3. So what's that? 9/4 pi. So if you add the, whoops, I forgot the pi over there. So I've got 9 pi over 4 above the x-axis, -1 pi over 4 below the x-axis. Those add up, I believe, to give me 8 pi over 4, which is 2 pi. So this is 8 minus 2 pi. 2 more. Find the value of g prime of 3. Well, that means we've got to find the value of g prime of x. G of x was 1/2 x squared plus the integral from 0 to x of f of t dt. So g prime of x is the derivative of 1/2 x squared is x, and then the derivative of this integral is f of x. All right, so g prime of 3 is 3 plus f of 3. So what is f of 3? Oh, f of 3 is negative 3. Big old 0. One more. Find the value of g double prime of 2. G double prime, okay? G prime is here. So g double prime of x, the derivative of x is 1, and the derivative of f of x is f prime of x. So g prime of 2, yep, double prime, I think, is 1 plus f prime of 2. Well, what's f prime of 2? There's 2, because this is f, so f prime is going to be the slope. Let me see here. This is the point 0, 3. Is that right? So the slope of that line will be 3 minus negative 3 over 0 minus 3. 6 over negative 3 is negative 2. That's f prime of 2. So that's 1 plus negative 2, negative 1. And I do believe that is that. Yep. I hope you liked that lesson. I hope you found it pretty easy and kind of fun. So I will post that for you if we need it.